Yes. Anything else? So we have 11, we have 5. Anything else? 14. Okay, we have 3 for now, and I'll ask you later. Okay, so sine x plus cosine y equals 2x minus 3y. Perfect. Good. No one can solve this equation for y. We are asked to find dy over dx. This specifically says find the derivative of y with respect to x, and also says x is the independent and y is a function. Do not treat it as a variable. Okay, so of course we will apply this operator to both sides. Sine prime is
cosine.
Yes. Now be careful here, because I need to differentiate the outer and I need to differentiate the inner. What is the derivative of the outer?
Negative sine.
Very good. Times the inner function prime.
Dy dx.
Perfect. On the other side, 2x prime. Good. Minus 3 times y. But y is a function, so I have negative 3 times the function prime.
Dy dx.
Very good. We are after, now this is algebra only, we are after this, but it's in 2 different terms, one on one side and one on the other, so I will move this term here, and then I have to move 2 to the other side. Every time I move a term from one side to the other, I change its sign. So I will have cosine x minus 2, and then I will have sine y, and minus 3, and as we did before, these 2 terms have dy over dx. That comes out. And finally, can anyone give us dy over dx? So we determine an yes, awesome, brilliant, awesome. That's it. So implicit differentiation has a lot of algebra in it, because as you see, calculus is only in this row. The rest is just moving terms around. It's a linear equation in dy over dx. And we only have to see it and solve it accordingly. So this was 11. Now we picked 5. Any questions on 11? I'm kindly asking you to redo these problems before you do anything else, until you understand them fully, please. Where's my mouse? Okay, here. Where is 5? Okay, so we have in 5, I'm on page 8. In number 5, we have x squared minus 4xy plus y squared equals 4. Perfect. Again, no one, I mean, this one is quadratic in y. We could solve it, but nobody wants to do that. We apply this operator on both sides. So we want to find dy over dx. This tells us 2 things. We want to find the derivative of y with respect to x. Y is a function, x is the independent variable. So, x squared prime. Anyone?
2x.
Good. Now careful that this is a product. So we have the first function prime, which is negative 4 times, yes. Careful with this because it's a minus, so I have to copy the minus again. So 4x times
dx over,
yes.
or dy over dx.
Yes, awesome. Now I'm here. This is a function to a power. How do I differentiate a function to a power?
Differentiate the function and then differentiate its power.
Always the outer and then the inner. Always the outer and then the inner.
So differentiate 2.
2 times
dy over dx.
careful. So we bring down 2 and we subtract 1 from the power times the inner function prime. What about 4 prime? If I have 4, yes, because if I have $4 in my pocket and I don't add on, don't subtract, it will still be there. Okay. Algebra. These two terms have the variable. These two have to go to the other side. So here I'm going to factor out. So negative 4x plus 2y with dy over dx. I factor this out, negative 4x plus 2y. These two go to the other side. I will put the first one as 4y and the next one is negative 2x. And finally dy over dx will equal what do I get?
4y minus 2 over negative 4x plus 2y.
That's it. Any questions on this problem? And then we want to look at 14. Any questions on this problem? Anything?
Yeah.
Yes.
You said it quickly, but I don't know whether I understand why.
Let's do it again. Yes.
The negative 4y minus 4x, that part, you just said, hey, it's negative, make sure you take that up. No, one line up, sorry. When you first, have the
Yes, because when I have, you can keep the negative outside and say f prime g plus f g prime, and then distribute negative f prime g minus f g prime, or keep in mind that you will have a sum and you can jump from here here. So if it's a sum and with minus in front, both terms will become negative.
Okay.
First function prime is 4 times the second one, and then minus the first function times the second one prime.
Right, yes.
Now, if this is confusing, do it in 2 steps. In other words, so when we apply this operator to both sides, do this. 2x minus first function prime is 4 times the second one plus 4x times the second function prime plus a function to a power, one more time, prime is n times f to n minus 1 times f prime. If this is power 2, I bring down 2, and then 2 minus 1 will be the function to power 1 times the function prime, which will be dy over dx, and 4 prime is 0. And then distribute. You don't have to do it in one step. Is this better?
Yeah, thank you.
Thank you. Other questions on this, please? Anyone else? Anyone? Okay, so we said again that we are going to 14. So let's see 14. And I'm on page 9. And you picked 14. Let's see 14. 14. This one. So tangent x minus y equals 2xy cubed plus 1. Okay. Now we're in business, really. Good. Yes, this one is not a friendly situation. No one can solve for y, of course. We will apply the operator to both sides. So let's take it easy first with this. So I have tangent of a function. Obviously this is the outer, this is the inner. We have to differentiate the outer and then times the derivative of the inner. So where is the tangent prime?
Secant square.
Yes. secant squared of indeed x minus y times the inner function prime, x prime,
1.
very good, minus y prime,
dy dx.
yes, good. Now, this is 0, I don't even have to look at it, but this is a product again. But since there is plus in front, I don't have to worry about putting parentheses and distributing anything. The first function prime is 2 times the second one, plus, again, we don't have to do pluses, I'm just telling you that please follow, it's not done. And then 2x, can anyone differentiate y cubed for us?
Y squared dy dx.
Excellent. We bring down 3, we subtract 1 from the power, times the inner function prime. Now the algebra here is slightly more involving. Why? Because I cannot remove dy over dx from here before I distribute this quantity to both terms. So be very careful here. This is not a friendly situation. Thank you for picking that. So this is secant squared of x minus y, and then secant squared has to be distributed in front of this, minus secant squared x minus y, but times dy over dx, and now I have to copy the whole thing again, equals 2y cubed, plus, I multiply these two, of course, 6xy squared dy over dx. Again, remember what I'm after. But careful, because one is on the left-hand side of the equal symbol and the other one is on the right. So I will bring this to the other side, and I will take this to the left. When I take this to the left, it will change its sign. When I take this to the right, it will change its sign. So then the left-hand side becomes secant squared x minus y minus 2y cubed. And on the other side, I will have 6xy squared. I will write plus secant squared of x minus y. And in one step, also factor up. Because now these two terms will be on one side, and they have the common factor that I'm after. So now finally, I have dy over dx. This was not a friendly situation because I had to be very careful with that the derivative here, and then distribute. I had to be very careful there. So can anyone give us the last part?
Secant squared x minus y minus 2y cubed over 6xy squared plus secant squared xy.
Just for everyone to remember, you cannot simplify the secant square from here with the secant square from here. Can anyone tell us why I cannot simplify these two? Because they are this and not that. Is not a, but a.
Not a factor, but a term.
Thank you. It's not a factor, but it's a term. We never simplify terms like that. Great, very good, well done. Any questions on this? This needs a lot of work. You have to redo this. If you really, really want to master implicit differentiation, you have to redo the problems we did several times. Okay, allow me now to choose one. And I would like to choose, I even let you choose if you want, anything from 27 through 36. You choose. what is this all about here is use implicit differentiation to find an equation of the tangent line to the curve at a given point. So you choose.
Let's do 29.
29 it is. Perfect. And on page 10, we chose 29, and let me copy it. X to 2/3 plus y to 2/3 equals 4, and they are giving us -3 the square root of 3 comma 1. Perfect. Awesome. Let me see the time. It's 15 minutes. Yes, I think we have time. I mean, I'm looking at my videos. Okay, so again, in this particular case, for this problem, I can solve for y, by the way. But we are practicing implicit differentiation. Let's do that. So, bring down the power, subtract 1 from the power. 2/3 minus 1, -1/3. Plus. Same thing for this, but this is a function. So we will have 2/3 y to -1/3 times what? Oh, of course, thank you very much. And the right hand side prime is
0.
excellent. So this is an easy situation because I only have one term. I'm only moving this term to the other side and dividing by that. So then dy over dx will be negative, because this will be negative, 2/3 at the top, x to -1/3, divided by 2/3 in the denominator, y to -1/3. The 2/3 from the top, 1, 2/3 from the bottom, 1. Now, remember, we have the point -3 the square root of 3 comma 1, which means y minus y1 equals the slope times x minus x1, where x1 is -3 the square root of 3 and y1 is 1, and we want to find the slope. How do I find the slope? I have the derivative. How do I find the slope?
Plug in x in.
Exactly. So we have negative in front, x -3 the square root of 3 to -1/3, and 1 to -1/3 is just 1. So this is the slope. Although it's very ugly, negative outside, negative, negative, so this is a cube root, so it will be negative, with minus in front, it will be positive. So let me explain all this, a little number. So, -3 the square root of 3, I don't know how they came up with, I mean, they have to, because, I mean, the point has to verify the equation, that's why it's so ugly. Okay, so this is -1 over, and you can write it as the cube root of -3 the square root of 3. And this is negative with negative in front, so this will become the cube root of 3 the square root of 3. And this is our slope. So then the equation is y minus 1 equals 1 over the cube root of 3 the square root of 3 times x minus 3 the square root of 3. We can probably simplify it a little bit. And let's see how we do that. That's page 11. So y equals 1 over the cube root of 3 the square root of 3 x, and then -3 the square root of 3 over the cube root of 3 the square root of 3, and then plus 1. Okay, so this is at power 1, and this is at power 1/3, and 1 minus 1/3 equals 2/3. But I won't be able to add the 1. It has to stay as is. So the cube root of 3 the square root of 3x minus 3 the square root of 3 to power 2/3 and plus 1. Can it get uglier than that? I doubt. So this is the equation of the tangent line